Assalamualaikum warahmatullahi wabarakatuh and good day. So in this video, you will learn a second method of chapter 4, function of random variable, which is the method of transformation. Okay, so previous lecture you have learned the method of distribution function, but now is the method of transformation. You have the same objective. You want to find the distribution function of u, and you want to find the density function of u, but now you use transformation. So given the density function of a random variable y, okay, the method of transformation result in a general expression for the density of u equal to hy, a function of y. If you remember in our previous video, you have done this for the last example. Okay, but that one is using distribution function. Okay, so the density of u equal with hy for n increasing or decreasing function of hy. Okay, so before this you only have u equal to y1 plus y2, for example, but now you have u equal with a function of y, for example y square in previous video. Okay, so this y, this function hy ni, is it increasing or decreasing lah? Alright, then if y1, y2 have a bivariate distribution, we can use the univariate result explained earlier to find the joint density of y1. Okay, so if you look in previous example, the last example for 4.2, okay, if you look my video is in video part 4. Okay, and then you will have u equal with a function of y1, y2. And then by integrate over y1, we find the marginal probability density function of u. Okay, that is our objective lah. Alright. So look at explanation here. So given a density function of u, okay, which is u equal with a function of y, provided that this function is either decreasing or increasing. Okay, and then by by a function y increasing means that if y1 less than y2, then function of y1 will be less than function y2 for any real number of y1 and y2. So you can look figure 6.8 ni. So you have y, okay, so y can be from negative infinity to infinity. Alright, so you can see that if you have this is the increasing function lah. So you can see that if here is y1, okay, so you can see that here maybe is y2. Okay, so when the function of y1 is less than y2, so you will get the function of y1 less than y2. So means that your y1 is less than y2. So you can see here, this is your u. So u is, oh sorry, this is not y, this is u, alright, which is function of y. Okay, so this one. So when you want to, this u, in order for you to get y, it will give you inverse function of u1. Okay, in this case, because we consider only one y. Okay, so similar for this one. Okay, this is u equal to hy. So in order for you to get u1, you will get a function of y. Okay, so don't confuse. So this figure is very important in order for you to understand how the transformation do. Okay, we have this u is a function of y. So in order for you to get y, you will need to find the inverse function of u. But in order for you to get u here, you can straight away get from the function of y. Suppose that a function y ni is an increasing function of y. Okay, from previous figure you can see, and that u equal to hy. Okay, this one. So y has a density function of this one. Okay, for sure lah. When we have a function of y, then the density function of y will be fyy. This one. Okay, so then the inverse function, okay, for u is an increasing function of u. Which is if u1 less than u2, then inverse function of u1 less than y1, and then because this one okay, you must understand the figure previous, okay, because you have here inverse function of u1, actually you get y1, okay, and then this one is less than y2, and then this one is actually inverse function of u2. Okay, so from figure 6.8, okay, previous figure, the set point y such that, okay, function y is less than u1 is precisely the same as the set point of y such that y less than equal with inverse function of u1. So here, right, you must understand this one, okay, because we have this one is u is a certain function of hy, okay, so y will be inverse function of u, okay, u1 lah. In this case here u1, here is y1, okay, and then this one u1 is a function of y1. All right, so that's why the probability of u less than u will be actually function y less than u, okay, and then this one, actually, in order for you to get u, it will be the inverse function of this one, okay, which is less than inverse function of u. So that's why we will get y less than inverse function of u, this one. So make sure you clear understand. So figure 6.8 is very important in order for you to understand the concept of transformation, okay. Or in other words, if you have distribution function of u, okay, this one can be obtained when you have distribution function of y and then you inverse this one. You inverse the function of u, okay. Then when you differentiate with respect to u, okay, you will get the density function, okay. So this one actually, you will have this one, okay. That's mean density function of y inside is inverse function of u, then you differentiate the inverse function of u with respect to u, okay. So in order to simplify this notation, okay, we will write this one lah instead of this one is too much, isn't it? So you will have finally like this, okay. So this is the density function of u, this is the distribution function of u. In this case, because our u is not only y1 plus y2, or it's not only y1 minus y2, because it's a function of y. So this y could be what? Y can be 2y, many lah, y square and so on. Okay, that's why we call a function of y inside here. Okay, thus we have acquired a new way to find density function of u that evolved from the general method of distribution function. Okay, this one actually when we are talking about distribution function. So here, to find the density function of u, solve for y in term of u, that's it. Find the inverse function of u, okay, and substitute this expression into the density function of y. Then multiply this quantity by differentiate the inverse function with respect to u. Okay, okay, for sure I will show you by using example. All right. Okay, this is example 6.6, page 311. So by referring example 6.1, which we have done that for using distribution function, okay, a random variable y, okay, this one there is a space, okay, amount of sugar produced with a density function given by this equation. Okay, that's mean 2y, and then your y is between 0 and 1. So here we are interested in a new random variable which is profit by this equation. So that's mean u is a profit equal with 3y minus 1. So the question asks you, find the probability density function for u. Okay, find fu by using transformation method. Okay, so we have done this using the distribution function. So you can refer that in my video, second video. 4.2 part 1. All right, but now we want to solve this one using the transformation method. So if you look the solution here, so we have the function of interest which is hy, because from the question we have u equal to 3y minus 1, isn't it? And then here in previous for transformation, actually u is equal with hy. So this is what we have lah from previous explanation, okay, which is increasing in y. Okay, because you can see that when you have y equal to 0, it's negative 1, but when you y equal, you can see it's increasing because from here 0 until 1. Okay, and if u equal to 3y minus 1, then when you do the inverse function, okay, of u, you will get u plus 1 divided by 3. Okay, because how you get this one? Actually, you will give this one in term of y, isn't it? So you have u equal to 3y minus 1, u plus 1 equal to 3y. So u plus 1 divided by 3, you get y. So this is what you get. Hey, a function inverse of u. So that's why you get u plus 1 divided by 3. And then when you differentiate this one with respect to u, you will get 1 over 3. So you can see here, you only have this one. You can use quotient rule as well lah. Okay, if you do quotient rule, this is your u, this is your v, isn't it? Or maybe you can see that you have 1 over 3 for sure lah. If you look here, if I break it down, u over 3 plus 1 over 3. So when I differentiate this one with respect to u, this one I get 0, and this one when I differentiate 1 over 3u with respect to u, you get 1 over 3 lah, isn't it? That's why you get 1 over 3 here. Right. Now, thus, the density function of u, okay, in order for you to get the density function of u, you will use the previous explanation. You have fy here, inverse function of u, and then you differentiate this one. So this one actually you've done here, all right? And then this one, actually you have from inverse is this one, okay, and then from the density function here you have 2y, isn't it? All right, so that's why you have 2y here become this one. So you get u plus 1 over 3, and then here you differentiate, you get 1 over 3. All right, so this one when you simplify, you will get 2u plus 1 divided by 9. Okay, when you simplify, and then if you look here, how you get here is actually y. So y equal to what? U plus 1 divided by 3. Then you simplify this one to the left to the right, you get 0. 0 plus minus 1, and then here you get u. Here will be 1 minus 3 minus 1. All right, so that's why you get 2 here. Sorry, this is not 1 minus 3, it's 1 times 3. Okay, so 3 times 1 you get 3, 3 minus 1 you get 2. So that's why you get this 2 and negative 1. All right, so this is the function inverse and the density function of u. So if you look here, this is more easier compared to the previous method lah. Okay, so the range over which fu is positive is simply the interval y between 0 and 1 transformed to u exists by the function of u equal to 3y minus 1. Okay, so this answer agrees with example 6.1. So you can check from previous video, you get the same answer like this. All right, so I think I will stop here, and then I will continue with next explanation. Thank you, class.